Hello everyone, let's find the general solution for this integral right here, x to the power n minus 1 by x to the power 2n plus minus k. So, like in the previous videos, let's start off with an example. So, let's choose n to be 3. That means we get x square dx by x to the power 6 plus minus k. Here, in fact, it will actually be better if you wrote 2 into 3, which is obviously 6, but I'll show you why. Because the numerator will be the same, and you can use the indices law where x to the power a into b will be x to the power a whole to the power b, or x to the power b to the power a. So, you there are two ways to write this, either x squared to the whole power cube or x cubed to the whole square. Now, if you do x squared to the whole power cube, you can't really go anywhere from there, and it will be very troublesome to solve this integral right here. But if you do the opposite, it will be very easy. So, x cubed whole square plus minus k. Now, this is kind of like in the previous video where the power of the numerator is just one off from the power of the denominator. But the difference here is that this is in the whole square form. But in this case, instead of choosing the whole denominator as your function, as your substitution, you just let this part inside the bracket as a substitution, and this integral will go very nicely. Oh sorry, this is not an example. Well, it is, but I forgot to choose a constant. Let's choose plus 3. This is also plus 3. And this will be x square. Oh wait, we have to do our substitution now actually. So u equals to x cubed, this bracket part, differentiate both sides, you'll get 3x squared dx. And here what you can do is, in this integral, you can multiply it by 3 and divide it by 3, because this du will be 3x squared dx, which is what we have in the numerator right here. So you'll get 1 by 3 du by u square plus 3. Now, what you can do is rewrite this 3 as root 3 whole square, because now you get a form which is integration of 1 by u square plus a square, where a is a constant, and its general formula is 1 by a tangent inverse of x by a. If we were in the x world, if we had a dx and this was x and this was a, of course, so this would be 1 by 3 1 by a, and our a is root 3 tangent inverse of u by root 3 plus c, which will be 1 by 3 root 3 tangent inverse of x cubed by root 3 plus c, and that is our answer for this integral right here. And if you want the beginning integral, you can write it as x to the power 6. Yes, things will start to look a bit crazy, but don't worry, it's just the tangent inverse. Now, from this example, let's solve for the general solution. So first, let's rewrite it as x to the power n minus 1 dx. Leave the numerator part alone, just the denominator. And this will be x to the power n square plus minus k. And let u equals to x to the power n, such that du is equals to n x to the power n minus 1 dx. We multiply this by n, divide this by n, such that this whole numerator part is this du right here. So you can simply write it as 1 by n du by x square plus minus k. Now, you will actually get two different kinds of answers based on if this constant is positive or negative. So I'll also be doing an example for minus k right away. So all of these steps are the same. So I'll just write it as dw by w square minus, let's just say, 4 square. Now the solution for this, we have, well, a formula for this, which is, let's say this was a square, it would be 1 by 2a log natural of w minus a by w plus a plus c, of course. And if it was positive, we would have the previous answer, the 1 by a tangent inverse of x by a, or w or z or u or anything, but that is our formula. So, and we can rewrite it as root k whole square. Now, case 1, we have plus k, x square plus k, or root k whole square. That means this integral will be 1 by n root du by x square plus root k whole square, which is 1 by n into 1 by a, which is our root k log natural. No, it is the tangent inverse of x by a. Oh wait, it should be u. So u by root k plus c. So finally we have 1 by n root k tangent inverse, and u is x to the power n by root k plus c. That's one big aeroplane. Now we'll have to move on to our case 2, where we will use this formula, and case 2, x square minus root k whole square. So that means we will have the integration 1 by n integration of du u square minus, I'll just remove the confusion, root k whole square. So this is 1 by n into 1 by 2 root k log natural of u minus root k by u plus root k, u by root k plus c, and this is just 2n root k log natural of u, which is x to the power n minus root k, and x to the power n plus root k plus c. And that is it. This is our general formula, and if you want to verify this, you can choose the value of n and find if that answer matches this answer or this answer based on case 1 or case 2. And if you want the proof for those 1 by 2a, tangent inverse, and other formulas, then please let me know and I will prove them for you guys. And if you learn something new, please like and subscribe. Thank you.